Okay, so we're going to be learning how to talk about integration by parts today. And remember that we just finished talking about substitution, which is the method that reverses chain rule. Now we're going to be talking about how to reverse product rule. So recall the product rule. It says the derivative of the product of two functions. So this u stands for like u of x, because this is a function in terms of x. Let me get my pen. Oops. Start inking. There we go. Sorry. Okay, my u is some u of x. It's a function of x. And my v is also a v of x. It's a product of two. So the product rule says this is u prime v plus u v prime. Okay, so the goal will be try to undo something that looks like this and get back to the original result. And so what we're going to do is we're going to use something called integration by parts. So actually what integration by parts is, you'll notice, is a formula where we start with some integral and we rewrite it in terms of another integral. Now the goal will be, of course, that this new integral is supposed to be something that's easy, quote, easy to integrate. And the first one, the one we start with, this one is something that we can't integrate. So just like substitution, you're starting with an integral and you're rewriting it in terms of another integral, but the purpose is to make that new integral something that we can evaluate. Okay, so let me just prove to you that in fact this integration by parts is actually just a rearrangement of the product rule, so that if on the test you forget integration by parts, you can, in theory, just evaluate, derive it yourself. So we start with the product rule. We have the derivative of u times v is equal to u prime v plus u v prime. And what we're going to do is we're going to just take the integral with respect to x of both sides. Now on the left side, the second fundamental theorem of calculus says if I take the derivative of an integral, so I can rearrange those two symbols, then I just get back to the original, u times v. And over on this side, we have the property that says if I have the integral of a sum of two terms, I can write it as the integral of the first term plus the integral of the second. And now we just do a tiny bit of algebra. We subtract this term, u prime v, from both sides of the equation, the integral of u prime v. Okay, when I subtract, I'm left with uv minus the integral of u prime v. That's the left side of my integration by parts, is equal to uv prime, the integral of uv prime. So that's the right side. So obviously my two sides of the equation are switched, but that's my integration by parts, and we're done. So this is called integration by parts formula. Okay, so let's view an example. And I'll leave just my formula showing. Okay, so we start with x times e to the x, and the goal will be to choose one of these, either x or e to the x. Choose one of them to be u and one of them to be v prime. And notice that when I take my use my parts formula, let me change colors for a minute here just to not mess with that. So if I choose one of them to be u, when I use it into the parts formula, the derivative is going to be there. And when I choose the other term to be my v prime, the antiderivative v is going to be there. So I'm going to be sort of changing my terms, my product from whatever it is, to the derivative of one of the terms times the antiderivative of the other term. So we're going to learn some techniques for sort of how to choose which one should be x and which one should be u and which one should be v prime. But in general, I hope it makes sense that if we're taking the derivative of one and the antiderivative of the other, e to the x is just e to the x. Whether you take its derivative or its antiderivative, it just stays e to the x. Versus x, if I take its derivative, I just get 1, which is certainly a simpler thing. And if I take its antiderivative, I get 1/2 x squared. So that gets more complicated. So the correct choice, or I guess the best choice, is I'm going to choose u to be x and v prime to be my e to the x. Now I know this is all written over here in typing, but I'm just going to show you how I do it each time. Okay, so once I have these two parts sort of established, I need to find the other parts of the equation. So the other parts being used are u prime shows up in that formula, so I better find it. The derivative of x is 1. And v shows up in the formula, so I have to find the antiderivative, right? I'm going from the derivative to the regular function, so that's the antiderivative e to the x. Now, what I wrote over here in the notes is I showed that v is actually e to the x plus c. But, and you can look through what I did, but ultimately that ends up canceling. And so I'm going to just leave it like this. This is what we'll do, is we will ultimately, as I say here, that the original c's cancel, so we could have just let v be e to the x. And from now on, that's what we're going to do. So let me just show you what happens if we do it this way. Okay, so we're starting with our original problem is x e to the x. That's our u v prime. And by parts, our result is supposed to be u times v minus the integral of u prime times v again. Notice that v gets used twice in my integration by parts formula, right? It gets used here, oops, sorry, there and there, right? It gets used twice, and v prime never shows up again. Okay, let me go back to my, I don't know what color blue I was just using. Okay, so anyway, the point is, oh, sorry, I'm having some pen difficulties. Here we go. Okay, so back over here, I have x e to the x, and the point is now my integral is something easy to find the antiderivative of. The antiderivative of 1 times e to the x is just the antiderivative of e to the x, which is just e to the x plus c. And so we're done. We finished that example. Okay, this second example down here just shows what we do when the integral is a definite integral. And so we know from the fundamental theorem of calculus that the antiderivative function would be evaluated at the top number minus the antiderivative at the bottom number. So all this second example is showing you is that you take your antiderivative, which we just found, that's right here, we'd evaluate it at 2 minus evaluating it at 0, and we get our result. So so anyway, that's just really talking about the second, for definite integrals. All right, let's look at another example now where we have nothing written for us, and I'm going to rewrite integration by parts here. Okay, so there's our parts formula. So we look at our function, we've got our integral, I'm sorry, we have two terms, an x squared and a natural log of x. So one of these has to be my u, and one of them has to be my v prime. So when I talk about which one to choose, well, one of them I'm going to take the derivative of, and one of them I'm going to take the antiderivative of. So I have to think about which one should be which. Well, the easy choice in this case is the natural log of x. I don't know how to take the antiderivative of. I only know how to take the derivative of it. Right? We know the derivative of natural log of x is 1 over x, but we don't know the antiderivative. So that makes it our easy choice that u is going to be the natural log of x, and v prime is going to be x squared. So the derivative of natural log we know is 1 over x, and the integral or the antiderivative of x squared is 1/3 x cubed. Okay, so parts tells us that this integral is equivalent to u times v minus the integral of u prime times v. And again, so I'm starting with an integral, and my result still has an integral in it, but the point is that now this integral is supposed to be something that I can evaluate. So if you're looking out for algebra, and this sometimes is a mistake students make, but we have to be looking for algebra, right? We don't want to take the antiderivative of each term individually. It's a product. So we have to look for algebra. We have got an x in the denominator. That's going to cancel with one of these x's here. So really what we have here is the natural log of x times 1/3 x cubed minus 1/3 x squared. And so now we see this is in fact something we can easily integrate. Okay, so we get, I'm sorry, I'm going to pull that 1/3 out front. I don't like my coefficients in the middle there. So 1/3 natural log of x times x cubed. And now I feel like I should put parentheses around my natural log of x. There we go. Minus the 1/3 stays out front, and I take the antiderivative of x squared again. So that is 1/3 x cubed again. And so our final result is 1/3. I'm going to move my x cubed out front too so I can avoid that parenthesis. Natural log of x minus 1/9 x cubed plus c. And there we go. Okay, this video is getting long, so I'm going to stop it and we'll do our next example in another video.